Okay, here we go with day 5. We're going to work more with differential equations and applications, applying them to physics. So we have this stone that's thrown from the top of a 320-foot cliff at 128 feet per second. It eventually hits a beach below. I need to find the highest point. Well, because this is in feet per second, I know my acceleration is going to be negative 32 feet per second squared. And then I can do, my velocity is the antiderivative of acceleration, which is negative 32 dt. Get v equals negative 32 t plus some c. And I could use 0, 128. So I got 128 equals 0 plus c, or c is 128. Or my velocity equation is negative 32t plus 128. That is my velocity equation. Well, one thing I know about the highest point, I know my velocity is equal to 0 because when I'm at a max, because when I do this way, my velocity is positive, and when I go this way, my velocity is negative. So I plug velocity equals 0. I get 32t equals 128, or t equals 4 seconds. So at t equals 4 seconds, it's at its maximum height. So what is that maximum height? Well, I need to do, and my height is going to be my antiderivative of my velocity, which is negative 32t plus 128 dt. Our height is equal to negative 16t squared plus 128t plus a c. I could plug in the 0, 320, or 320 is equal to 0 plus c, or c equals 320. So my height equation is equal to negative 16t squared plus 128t plus 320. That is my height equation. And since my time was 4, my height at 4 is going to be, well, let me go down a little bit lower. It's going to be negative 16 times 4 squared plus 128 times 4 plus 320. I get my height at 4 is equal to 576 feet. That is the maximum height. So I want to know how long it's going to be in the air when it hits the ground. That's h equals 0. I take my height equation, negative 16t squared plus 128t plus 320. I don't want to work with those big giant numbers, and I realize I could divide by negative 16. So 0 equals t squared minus 8t minus 20. I could factor this. I get minus 10 plus 2. So I get t equals 10 seconds. That's how long it's up in the air. And then this one is t equals negative 2, which is impossible. So my velocity at 10 seconds will just be negative 32 times 10 plus 128. My velocity at 10 seconds will be negative 192 feet per second. And this is no person or any physical world. It's a little extreme because it's 131 miles per hour. A little bit fast. So let's say you're driving at 60 miles per hour and you see a deer 150 feet away and you slam on the brakes and it takes you 4 seconds to stop. Are you going to hit the deer or not? Well, constant acceleration means linear, which A is change in V over change in T, which is negative 88 feet per second divided by the 4 seconds, which I get negative 22. So my acceleration is negative 22 feet per second squared. My velocity is equal to the antiderivative of my acceleration, which is negative 22 dt. I get V equals negative 22 t plus c, but I know what I have initially. I know when t equals 0, my velocity is 88. So 88 equals 0 plus c, or c equals 88. So my velocity equation is negative 22 t plus 88. And now my distance will be the antiderivative of my velocity, or negative 22t plus 88 dt, or my distance equation is negative 11t squared plus 88t plus c. But I do know when t is equal to 0, I haven't gone anywhere. So 0 equals 0 plus c, or c equals 0. And let me box some things up here. Or my distance equation is equal to negative 11t squared plus 88t plus, plus 88t. But I know I have it at t equals 4. So my distance at 4 seconds is going to be negative 11 times 4 squared plus 88 times 4. My distance at 4 is going to be 176 feet. Well, yes, I'm going to hit the deer, so I'm going to have some roadkill, or I get to bring home some venison for dinner. Okay, for this next problem, I'm just dropping a ball. So at t equals 0 at the beginning, I know I have no velocity. The ball does not have a velocity, and because I'm using, when it hits the ground, it has a velocity of negative 80 meters per second. Because I'm using meters, I know my acceleration is going to be the metric negative 10 meters per second squared. So I want to figure out the height of this cliff, or whatever you want to call it. So I know when height equals 0, my velocity is negative 80, but I don't know the time for that. But I can do my v equals my antiderivative of a, which is my antiderivative of negative 10. So v is equal to negative 10t plus c. And I know I have 0, 0. I could plug them in here. So c equals 0. So my velocity equation is negative 10t. And this is what I have so far. And then I can use that and say my height is going to be the integral of my velocity, which is going to be negative 10t dt, or it's going to be negative 10, oops, that's not right, negative 5t squared plus c. Clean that up a little bit. Okay, what do I do? What do I know? Oh, going back to this one. Well, I need to figure out my time. I know I have negative 80 is equal to negative 10 times t, or t equals 8 seconds. When it hits the ground. So I could come over here and figure out what do I need to have. So I know at 8 seconds it hits the ground, or h is equal to 0, so the height is equal to negative 5 times 8 squared plus c, or 0 equals negative 320 plus c, or my c is 320, or my initial height is 320 meters. That's pretty high up. So for this next problem, I have this inclined plane with this block, and at t equals 0, I don't know the velocity. I know acceleration is 8 because that's given to me. I know its distance, its travel is 0. But then I do know that at 3.75 seconds later, it's gone 75 feet. So a is equal to 8. My velocity is my antiderivative of a, which is of 8 dt. So my velocity equation is going to be 8t plus c. But I don't know in my initial c, so I'm not going to call that c. I'm going to call it some initial velocity. I just call it v sub 0. Don't know what it is, just call it v sub 0. Well then, I could say my distance is my antiderivative of my velocity, which is 8t plus v sub 0 dt. So my distance is equal to 4t squared plus v sub 0 times t plus some initial distance. Well, I think I've established that this is just going to be 0 because I don't have anything. So my distance equation is going to be 4t squared plus some initial velocity times time. And then I can use this information here. So I'm going to do that over here. My distance of 75 is equal to 4 times 3.75 seconds squared plus v sub 0 times the 3.75. 75 is equal to 56.25 plus 3.75, my initial velocity. 18.75 is equal to 3.75 times that initial velocity. I divide by 3.75. I get my initial velocity is 5 feet per second. That's what I have for that. So I want to figure out how long a runway must be if a jet needs to be going 100 meters per second to take off, and it accelerates from 0 to 100 meters per second in 25 seconds. Basically, if I don't tell you, for the most part, we're going to presume linear. So my acceleration is going to be change in v over change in t, which is 100 over 25. So my acceleration is 4 meters per second squared. So when I want to find my velocity, it's the integral of that, of a, which is 4 dt. So my velocity is going to be 4t plus c. But I know at the very beginning, the plane is sitting still, so my distance is 0 and my velocity is 0, so I could call that 0. So my velocity is just 4t. If I want to do my distance, it's the integral of v, which is the integral of 4t dt. So my distance is just 2t squared plus c. But again, I know initially I have 0 distance. So my distance equation is 2t squared. Well, I'm going to use t equals 25. So my distance traveled in 25 seconds is going to be 2 times 25 squared. My distance at 25 seconds is 1,250 meters, but I need my safety factor. My safety factor is going to be times 2.5. So the runway length will equal 3125 meters over 3 kilometers, or about 2 miles, which seems about right for a jet engine. It's not going to be a half a mile long. It's going to be very, very long. Okay, thank you for watching.